Emilio?
Yes, just a moment.
It's all right. I think it's important right at the start to decide what you want to get from astrophotography. And there's really two separate types of astrophotograph. Firstly, photographs of astronomically significant or astronomically interesting objects, or pretty objects, or simply using the night sky as an element in a night photograph. And again, a lot depends on how much time, how much effort, how much money you're willing to spend, but importantly, how much suffering you're willing to actually put in. Astrophotography, while you take it back, takes place when it's dark. And when it's dark, that means it's cold, it can be breezy, there's the lure of a nice warm bed, there's other things you might prefer to do than be out on some hillside at night. Just to check, did we miss a slide there, Emilio?
Sorry, this one. Okay, this one.
Yeah, that's it. Yes, thanks. So it's not straightforward, isn't astrophotography? It can be a case of the more you spend, the better the results you can get, but you can get a lot of good pictures by not with existing equipment. And what I'll do is try and explain how to get the best out of what you've got. Also, if you want to spend a little bit more, what you might wish to spend it on. There's some big challenges in astrophotography. The main one is that astronomical objects, apart from the sun and moon, are all very faint. That means you are dealing with long exposures and wide apertures on your lenses. You'll need to whack up the ISO on your camera, but that will also enhance your noise from the sensor. And sensor noise is a big limitation. Some cameras perform better than others. I would say that things like the Sony A7, some of the Nikons, some of the Fujis probably are the leaders in low sensor noise. But you know, I shoot with a Canon 80D, so you can get away with other cameras producing perfectly good images as well. A big problem is light pollution. Depends where you live. People like Dave live out in a lovely dark sky area and you can just walk outside of his back door, and it's excellent for astrophotography. Other people may live in a more urban location and you go out of the door and you're lucky to see more than a few stars. So in most cases, to avoid the worst of light pollution, you need to travel to somewhere with a bit of a darker sky. We can't stop the Earth spinning on its axis, sadly, and because the Earth moves, the sky rotates above our heads, and that means that anything you try to photograph with a long exposure just turns into a trail. So to overcome that, you have to use some specialist equipment or specialist techniques, or both, but it can be overcome. Now, once you can take photographs with both wide angle and telephoto lenses, a lot of the astronomical objects have a small angular size, which means a long telephoto lens or a telescope is extremely useful. Now for this presentation, I am assuming that nobody has a telescope and nobody's going to go and buy one. So I'm not going to cover astrophotography with telescopes at all. I'm just going to focus on using your camera and your lenses on that camera to take pictures. With astrophotography, planning and practice are really important. You need to know where, when, and what to photograph. What is there in the sky to actually point your camera at and get the image? Fortunately, there's an awful lot of great information on the web and some very useful apps you can have on your phone or tablet to help you. In terms of what to photograph, there's some great things. If you Google something like best 15 winter astrophotography targets, you'll come up with some good sites which will point you at the best objects to try to start photography. If you want the best imagery, then you need to travel to a really dark site. The darkest sites we have around us are Cabo de Gata, which I've been to on several occasions for astrophotography, Sierra Cazorla, and Cala Alto. The latter two are further away, but if you happen to be taking a holiday up in that direction, it's a great opportunity to do a bit of astrophotography. Unless you are intending to photograph the moon itself, the moon is a nuisance. It is a big source of light pollution. So avoid a bright moon. At the moment, the moon is about 80% full, so it's just the wrong week to be doing astrophotography. A week's time, the moon will be past full, and you'll get a nice window after sunset to do a bit of astrophotography.
Oh, yeah.
One thing to be aware of is when you're outside, it's going to be cold. Rod, your microphone's on.
Yeah, it's okay. It's finished now.
All right. So make sure you don't get cold. Your own welfare is far more important than any photograph. So make sure you wear suitable clothing to keep warm, especially on the winter nights. The summer nights in Spain are nice and mild, but the winter nights, certainly not. And even where somewhere like Dave lives, the summer nights probably get quite cold. It's important to actually learn to operate your camera in the dark. You can just try that in any room in the house. Turn the lights off, see if you can find the playback button, the magnify the image on your live view button. See if you can identify and change the ISO on your camera. Can you change the f-stop and the shutter speed? So get to know the feel of your camera so you know which button is where, so you can press it in the dark. Because your eyes take 2 minutes to fully acclimatize to normal ambient daylight. Your eyes take an hour to fully acclimatize to the dark. So if you put a torch on and dazzle yourself, it's going to take your eyes an hour to fully recover their night vision. So you don't want to be using a bright torch on your camera to try to see what the settings are or change something. Okay. Oh, I did comment there, and I just missed it. Leave this image up. To help, do take reading glasses if you need them.
Sorry.
Just go back one. Do take reading glasses with you. I need reading glasses. Also, a magnifying glass can be quite handy because you need to ensure you'll be using manual focus. You need to ensure things are pin sharp. And if you use glasses, take them. Now, a dim red light, as in the next picture, can be a great help. This is a head torch which has got white LED light in the center and red LEDs for night vision. Using dim red LEDs won't damage your night vision. So it's very useful to give you a faint glow. And I picked this up brand new off eBay for €10. They're quite cheap on eBay and well worth it if you're going to do a bit of night photography, even if it isn't just night astrophotography. Yeah. If you're not familiar with constellations and what is where in the sky, just stepping outside at night, it can all seem quite daunting. Where do I point my camera? What is there to be seen? How do I find things? Well, I mentioned there's some good apps. There's a whole string of apps. I've listed just two here, Starwalk 2 and SkyMap. These are two that I've had a look at. There are others out there as well that may be as good, maybe better than those two. But they will show you what the night sky is at your current time outside. So they'll identify the constellations, show you where the Milky Way is. If the center of the galaxy is visible, it will show you that, show you the positions of the planets. So it's very useful. But if you want to photograph deep sky objects, some of the images that you might see in books or on the web of astronomical objects, those simple apps really aren't detailed enough to show you how to find those objects. And certainly if you're pointing a telephoto lens at it, you need to point it quite accurately at something which may be so faint that you can't actually see it through the camera. So you need to know exactly where to point. And this is where Norton's Star Atlas, for me, is unbeatable. The next image shows a page from it. It might look a little daunting. Each star is marked with a size of dot according to its brightness. Use the app to find the constellations and then switch to Norton's for finding the specific objects. And there is a whole list in Norton's telling you where they are, and this sort of a guide really helps. I had a quick look on eBay, and there's something like 20 copies of Norton's Star Atlas on there used for about €5 each. So it's really cheap. And if you want to photograph deep sky objects, photograph an external galaxy or photograph a nebula, for example, using something like this to make sure you're pointing in the right place is really helpful. Yep. So what to actually photograph very much depends on your equipment. The moon, well, that's a doddle for almost anybody with an SLR camera. It's absolutely easy and probably the first thing to try to photograph. The sun, well, you've got too much light. It's dangerous to point your camera at it. Don't do it. Don't risk your eyesight. Don't risk your camera. You mostly need specialist equipment. The exception is if you've got a misty sunrise or a misty sunset or some very hazy cloud, you can actually take a direct photograph. Even then, I would recommend you use the camera on a tripod and look at it through live view rather than risk putting your eye to the camera when it's pointing with the sun in the field of view. To get images of the planets, a telescope is essential, so I'm not going to cover those again in this presentation. Probably one of the most rewarding things to photograph is the Milky Way and galactic center, and it's relatively easy with an SLR or mirrorless camera to capture that. And we'll have a look at that this morning. Some of the most beautiful things are nebulae, which is the areas of gaseous cloud where stars are being born, star clusters, and galaxies, which are whole cities of stars. They're quite beautiful objects, but tracking equipment is needed to actually get a decent image of these, and there's only a few bright ones. So without specialist equipment, they're going to be beyond us. But you can make your own specialist equipment, and I will show you a little bit later how that's done. Meteors, they're quite easy, but meteors, once we have a few any particular night, it's best to focus on a limited number of days per year when we have what are called meteor showers. And basically the Earth goes around the sun once a year in its orbit, and every so often in that orbit it passes through a cloud of debris, and that gives rise to the meteors or shooting stars. They're pretty easy to photograph with a wide angle lens, so we'll see a little bit of that later. Comets, well, these are probably the most beautiful thing of the lot, but bright ones are very rare. We were treated to comet Neowise 2 years ago, and that was the first bright comet that we have had for probably 20 years. There have been a few other naked eye comets, but not as good as Neowise was last year. Lunar eclipses, they're easy to photograph, and they come about a total eclipse comes about once every 2 years. The next one is on the 16th of May next year, and that will be visible to all in Spain, probably also the rest of Europe. The next two come both in 2025, so it's 3 years wait after the one in May next year. Solar eclipses, partial eclipses, equally as dangerous as photographing the sun itself. You need specialist equipment to reduce the brightness of the light, mylar filters or something like that. But plan ahead, and in Spain we're going to be extremely lucky, because in both 2026 and 2027 there are 2 total eclipses of the sun, and the one in 2026 in August will be total and visible from the tip of the Cabo de Gata, so you don't have to travel very far for that one. From Oaxaca it will be something like 98% totality, but it is well worth going to totality because the difference is enormous. Okay. Equipment. What do you need? What are the attributes? As I mentioned earlier, excellent high ISO noise performance is a godsend. Not everybody will have that on their camera, but if you have, you're lucky. What you do need as essential is a bulb setting, the ability to keep the shutter open for a long exposure. Use a remote release. Do not use your finger to press the shutter button. It will cause vibration and shake. Always use a remote release. Live view is a terrific help because you'll need to use manual focus, not autofocus. And live view will allow you to get the focus spot on. Now, if you're willing to throw some money at the problem, and you've got a lot of money to spend, you can get what is called a full spectrum sensor conversion. They're about €250 to convert your camera, or you can buy a camera with one already converted. What that means is that the sensor in your SLR camera that you've got now actually has got a filter over it to block out the infrared and reduce the red to give you a decent colour balance and not have it swamped. That filter needs to be removed for the best astrophotography. Hydrogen gas emits a lot of red light, and hydrogen gas is one of the most beautiful things to photograph in the galaxy. So by removing the filter from your sensor, you can get much more sensitive camera for astrophotography. But as I say, you've got to be keen to spend the €250, and once you've done it, it's no use for general photography. So that's quite a commitment, and it's not one that I've done. Lenses, go for the widest aperture lens you can. You've got a wide angle. The widest angle is great for Milky Way meteors. Anything from 24 millimeters on an APS sensor, 35 millimeters or wider on a full frame. Telephoto lenses for the astronomical objects, you need to be looking, I think, at more than 300 millimeters full frame, 200 millimeters on APS sensor. And that's for photographing nebulae, clusters and galaxies. There are some filters that can help you. One of the problems we've got is light pollution. And even where Dave lives, there is light pollution in the distance affecting the horizon. So certain filters will help to cut out some of that light pollution. There are things called a neodymium filter or didymium filter, sometimes called the Starscape filter, and that cuts out some of this pollution. In the extreme, you can buy something called an ultra-high contrast filter, and that is superb for photographing the Milky Way and the gaseous nebulae. I'll show you those and how they work in a moment. Next.
Right.
Just to put it in perspective, go back one.
Sorry?
Back one. You've gone 2 slides, that's it. Yeah, thank you, Emilio.
Welcome.
Just to illustrate what I use a Canon 80D, which is an APS size sensor, and it is unmodified. I've recently bought a Sigma 24mm f1.4 art lens, which is lovely and sharp. Bought that secondhand off eBay. Very, very pleased with it. I've had for some time a 10 to 22mm EFS lens at f3.5 to 4.5, which I tend to use that at 10mm for really wide, and my Sigma because of the f1.4, if I can get away with the 24mm. I've also got a 55 to 250, which when you look at APS size sensor, that is getting to be equivalent to a 400mm on a full frame at the top end. But it's rather slow, f4.5 to 5.6. But it's absolutely beautifully sharp. It's the sharpest lens I've ever owned. I've got a Sigma 70 to 210 f2.8, which is a lot of glass in it. Cost me 3 times what the other lens cost me, and isn't as sharp as the Canon, but it is f2.8. Filters, I've got both a didymium filter and an ultra high contrast filter. I've also got a solar telescope, and I'll show you, if I can share my screen at the end, a photograph with that, just to see what that gives. Okay, next image. In understanding filters, a little bit of basic physics on light. A lot of you will know this as photographers. Some of you may not. If you heat any object up, it will glow and emit light, and it emits lights at all wavelengths. Light is just an electromagnetic wave. Long wavelengths are red light, short wavelengths are blue light, and somewhere in between is green light. In the galaxy, we have all kinds of atoms, and atoms are made up of electrons, which are negatively charged, orbiting around a nucleus of protons, which are positively charged. And because of the energies in some of these objects in space, the electrons get stripped away from the nuclei, and they like to recombine. Opposite charges attract. But one of the quirks of physics is that an electron can only orbit a nucleus in a specific orbit. And those orbits are different for every physical element. So they're different for hydrogen, different for helium, different for oxygen, different for neon, for example. And when those electrons recombine with the nucleus or the protons, they fall into the specific orbits, and they lose energy when they do. But because those orbits are fixed for each electron, the light that is emitted at a unique specific wavelength. And it's the same for every hydrogen atom. For example, it will only emit at a certain individual specific wavelength. And this is the principle of fluorescent tubes. You put 220 volts across whatever fluorescent tube you've got, and it strips the electrons off the protons, they recombine and they re-emit the light. And we all know that a neon light is bright red, and that is because when it recombines, the jump between the different orbits gives light which is at a specific red wavelength. If we look at mercury lamps, they emit in the blue and in the red and in the green at a multitude of specific individual lines which approximate to white. This actually is useful for us because if you go to the next slide, we can look at how a filter blocks light. The filter is the dark blue line, and this is a didymium filter, and the vertical lines are the main lines emitted by sodium vapor lights and mercury vapor lights, which are mostly used in street lighting and flood lighting. So you can see from this that the filter lets through an awful lot of light, but has a trough blocking some of the worst light pollution. So if you put one of these filters over your lens, you can block out an awful lot of that light pollution and still capture most of the light coming from the source. We go to the next one, that's taking the same thing to an extreme. This is the ultra high contrast filter. which effectively works the other way around and only passes or only allows to pass specific wavelengths. Astronomically, the most important wavelengths are from hydrogen. And as you can see on the graph on the right, if you can't read it, the big orange line on the right is hydrogen alpha line, which is a red line, and the hydrogen beta line on the left and oxygen lines are coming up into the blue. And everything else is cut out. And this filter creates superb images tracing out the oxygen gas and the hydrogen gas distribution in our galaxy. And I'll show you a couple of examples of that later on. These are not cheap filters. I bought this one second-hand, and this cost me something like 150 euros second-hand. So they're not cheap, because they're very highly engineered. And they fit between the lens and the sensor. So first time you put one of those in, it takes a little bit of nerve to do it. You've not put a filter there. Anyway, that's that. Capturing the image. It's absolutely vital to use RAW, not JPEG. We are dealing with very, very small amounts of source data. JPEG will throw some of that away and it will never come back. So use RAW. You can use RAW in 16-bit or 8-bit. Again, not to throw data away, use 16-bit. It's a higher memory usage, but it's well worth it. Switch the camera to high ISO. I tend to shoot on mine 3200 or 6400. If your camera is better than mine, you'll be able to go higher still. Use the widest viable aperture. And that I mean, use the widest aperture on your lens, but if it's not quite sharp, stop it down 1 or maybe 2 stops to get it sharp enough. Use manual focus and manual mode. And focus, how to focus in manual focus is point your camera at a bright star, use live view, zoom in to the full magnification, and then just tweak the focus. And then a tip that I only picked up in the last week or two, use a bit of sticky tape, a bit of masking tape, to tape your focus barrel on the camera so you don't accidentally knock it. I did accidentally knock mine, and I wrecked some of my best images that I would have otherwise had. Use a cable release, and if you've got long exposure noise reduction facility on your camera, turn that off. You will find, especially in wintertime, you get condensation on your lens. So use a lens hood and or a lens warmer. The next image shows a lens warmer. Again, about 15 euros off eBay. It's powered from a USB source. I use a power bank, and that is just a heated Velcro strip that you can wrap around your lens, and it keeps your lens nice and warm and stops condensation. Okay. Your last big challenge is stopping the Earth going round, which we can't do, but we can stop its effect. If you've got nothing else, use a short exposure. And there's a formula there which is the maximum exposure that you can get away with. And it's 500 divided by your focal length and divided again by a crop factor. If you're shooting with a full frame, crop factor is 1, so you can forget it. If you're shooting with an APS like me, it's 1.6. Either shooting with a micro four thirds like Emilio, it's a crop factor of 2. So that's your simple equation. A more detailed equation, depending on where you're pointing your camera in the sky, can be found on www.lonelyspec.com. That's helpful. But basically, I would suggest with an exposure, you try this, you go to playback, magnify it, and have a look to see if there's any trailing on the live view. But a way of combating this is you can stack multiple images, and that really is probably the most powerful tool we have in astrophotography, and I'll explain that in a short while. Yep. The second way is to use an astro tracker. I bought one a couple of years ago. Commercial ones typically are about €350. The usable ones are. Or you can make your own for about €20. I did, and I'll show you how to do that. Yeah. But either way, you need to align it with the pole star, which means you've got to find the pole star. So the next image shows how to do that one. We can all recognize the plough, the Big Dipper as the Americans call it, the Great Bear, Ursa Major, lots of different names. It's one of the most easily found constellations. If you take the 2 right-hand stars, extrapolate them upwards, they point to the pole star. And if you have a tracking device, that's what's to point it towards. And the closer you can get to accurate pointing, the better. The next image shows my setup. And so I bought, this is the Skywatcher Star Adventurer Pro. This just is a motorized device, simply tracks the stars with the Earth rotation. But you don't need to spend €350 on that. You can make one. The next image shows one I've used for 40 years. Made from 2 planks of wood, a bit more wood, 2 brackets, some elastic bands and a bolt. And that's all you need. And it works brilliantly. This will take a photograph tracking astronomical objects for up to 15 minutes. Important things are the angle that you have to cut, the angle of the two large planks is your latitude. The Mahaka is 37 degrees. The thread is a 1/4 inch British Standard Whitworth, or any thread which is 20 threads per inch. I'm sorry, it's imperial. For continentals, you might think that's a bit primitive, a bit anglicised, but you will know this thread because everybody has got one. It's what holds your camera to your tripod. That is a 1/4 inch BSW bolt. The distance from the bolt to the hinge has to be 28.5 centimetres or 11.2 inches. You've managed to make yourself one of these from bits of spare wood. You then turn the bolt at 1 turn per minute and away you go. It tracks, and it tracks brilliantly. The next images just show you each of these bits in close-up. So this bolt to hinge distance is 28.5 centimetres. Next one. The angle that you cut that angled plane is your latitude, or 37 degrees. Here in the UK, and on this photograph, because this is in the UK, it's 54 degrees for my latitude, 52 degrees if you are London latitude. Next one. That's the bolt that just goes through. I wedged a nut in the plank nearest to the bottom, and it just pushes the plank open at the top with a few elastic bands to hold the two tight together and give it a bit of tension. And the next one, a simple way of having a rod. I couldn't find a rod, so I used a key. And all you do is crank that key round with your finger at 1 turn per minute. And you don't have to be too accurate. If using that equation, it says that you've got a 10-second exposure, you can have a 10-second error in your pushing this round with your finger and it won't show. So it's very simple. It costs about €20 for the bits and pieces. If you want to put a tripod head on it, then that costs a little bit more. If not, just use 2 right angle brackets back to back, and that gives you full flexibility at pointing. Okay, next image. The last thing I'm going to talk about is stacking images. And there is an enormous benefit because it improves the signal to noise. You get a lot more signal and your noise is averaged down. So it really, real boost to your astrophotography. And for a lot of images, it can eliminate the need for tracking. The problem is you've got to learn a bit more software. There are 2 packages that I recommend. First of all, Deep Sky Stacker, and secondly, Sequator, which is like Equator but with an S at the front. If you're going to go through this, you need to take a set of images in addition to the photographs that you're taking of your object. And these are called dark, bias, and flat frames, and I'll explain those in a moment. They're important to reduce the noise in your image. If you don't track, it can be that lens distortions limit the total exposure that you can do with stacking, but you can still get some great images even if you're not tracking with a tracker. Okay. I said you need to take these other frames, and just to explain a bit of terminology, you'll find the software refers to light frames, and they're the subject, whether it's the Milky Way or a galaxy or whatever. It also refers to dark frames, and these are for noise reduction. And what you do to take a dark frame is put the lens cap on and just carry on. So if you've taken lots of photographs, say at 10 seconds at f8, ISO 5000, you put the lens cap on, you take some more photos at f8, ISO 5000. Nothing else changes. Then there's bias frames, and this is to do with how the sensor data is read off by the camera, and that can introduce another form of noise. And to try and take that out of your data, you have used the same aperture, use the same focus, the same ISO settings, but use the fastest shutter speed available on your camera with a lens cap on. In my case, that's 8,000th of a second. So the bias frames you can take in a few seconds, so that they're not really time consuming. If you've got a lot of problems with vignetting on your lens, you might want to take flat frames. More often than not, I don't bother with flat frames. But if you are suffering from a lot of vignetting, it's worth taking a few. Use the same aperture, focus, ISO again, but you need to have a uniform grey illumination. One way of doing it is to put something like a white handkerchief over the lens and fire a flash gun at it using aperture priority or shutter priority to define its own exposure. And for the darks, biases and flats, take a minimum of 6 to 10 exposures so they can be suitably averaged. Yep. The first of these two software packages is called Deep Sky Stacker, and I think that's the best one for astronomical objects. It's not very user friendly. In fact, it's pretty awful. However, there is a superb user guide, and that is probably the longest web link you'll ever see given to you. It's in there. You'll probably be able, by Googling Sky at Night magazine, Deep Sky Stacker user guide, be able to find it. If not, just look at the recording of this presentation to get that detail. Next, this is the interface of Deep Sky Stacker. You've got a single image, and as you can see in there, there's not much in that image, and if you're photographing faint objects, you won't see much in your basic image. On the left, I'll zoom into that in a moment on the next slide. You've got your input, and down the bottom is a list of data. Now, I'll just go, I don't know if you can see on your screens, but one of the columns in the data is a column called Score. And Deep Sky Stacker looks through and evaluates the quality of each image. And on the example here, all of them are around about a score of 1,000, but the third one has a score of 600 and something, which means it's a poor image for some reason. And you've got the option then to remove that image from your stacking to get a better quality result. Next one. This is the input, and as you can see, you've got dark files, flat files, ignore dark flat files, and then you've got the bias files. And basically you just load each one of those in by clicking on that, and then go down to register the checked pictures, which stacks them, and then finally stack the pictures down the bottom. The guide will tell you how best to set the defaults in there. Sequator, I find this the best for night sky landscapes. So if you want the Milky Way behind something, for me, use Sequator. It's free software. All of these are free software. But its great asset is it can freeze the horizon. If you make an approximate selection of the horizon, and it doesn't have to be too precise, and tell Sequator that's the horizon, it won't stack the horizon images and will only stack the star images that are effectively moving across the sky. So it's very good for that type of image, and it's a bit more user-friendly, I think, than Deep Sky Stacker. Yep. That's the Sequator interface, but I won't say anything more about that. Yeah. Oh, I did want to zoom in onto this one element because you can see down there near the top, sky region full area. If you are using this for a scene, that's the bit you need to tick and change to define your own sky region. And that is where you define in Sequator the horizon. Okay. Is it worth the effort stacking? Well, I'll let you decide that. The next image is a photograph, straight photograph This is f5.6, 15 seconds, ISO 6400, and you can probably just see a misty patch in the center of the field. However, if you go out and stack 60 of these together in Deep Sky Stacker, you come to the next image. Simple as that. Is it worth it? Yes. This is the Pinwheel Galaxy. So you can see the difference that stacking multiple images makes. Radical difference. Okay, next one. How do you process the image? Well, there's no escaping image processing software if you're doing astrophotography. You have to do some. Photoshop and or Adobe Camera Raw are the main tools you probably use. There are specialist astrophotography processing packages, most notable of which the Rolls-Royce one is Pix Insight. I haven't got it. It's as complex to learn how to use as Photoshop, if not more so. And I've decided Photoshop and Adobe Camera Raw, which is accessed both from Lightroom and Photoshop, are more than adequate. There are processing packages within Deep Sky Stacker and Sequator. Don't use them. They are incredibly crude and do not give you a very good result. If you use Deep Sky Stacker, don't be put off. The output image looks dull. It looks every bit as dismal as your original images you put in, but there is an awful lot of data in there. Put it into Photoshop or Adobe Camera Raw in the first instance, and you will see what data is in there. And I'll show you that difference in a moment. There's a number of plugins, most of which I use. You will find either that there can be a gradient caused by the difference in the darkness between the high sky and that near the horizon, which tends to be a linear gradient, and there can be a gradient caused by vignetting from your lenses. Those gradients can be removed by plugins, the Rolls-Royce of which is Gradient Exterminator. It's about 70, 75 euros, so it's not cheap. Astro Flat Pro is almost as good, but not quite. I use Astro Flat Pro, and that's about 25 euros. Another 25 euros will buy you what is called Carbonis tools, or the Astronomy Tools Action Set, most of which is useless, but there's a few things in there, like the ability to enhance deep sky objects, which I find very useful, and I use that on all my nebulae and galaxies. That costs about 25 euros. If you buy one of those, you get the other one at something like half price. But very useful, and this is really useful for general photography, not just astrophotography. I can strongly recommend Topaz Denoise, Topaz Sharpen to a lesser extent, and also if you are magnifying an image an awful lot, Topaz Gigapixel. That can be quite useful. Next. So, how do I actually process my images? Having put it through Deep Sky Stacker, if I'm using it, I start with Adobe Camera Raw from Lightroom or Photoshop, and I make basic adjustments. I adjust the contrast, I adjust the exposure, I adjust the levels, I'll make a curve adjustment. I'll then transfer it to Photoshop and use a plugin to remove the gradient, or I will go and stay in Adobe Camera Raw and use either the circular gradients or the linear gradient to try and remove it. And certainly if you haven't got a plug-in, you need to do that in Camera Raw. I then use a plugin, which is usually the Enhance Faint Detail. I will then make levels and curves adjustments and make a fine adjustment to the color balance. I'll then reduce the noise with Topaz Denoise and the final polishing with levels, curves, and any further change to hue and saturation. So I'll now take you through that on the Orion Nebula. So the left-hand image is the image that you will get at the end of using Deep Sky Stacker. As I said, it's quite dismal, it's quite faint, but it's got a lot of data. Transfer it to Adobe Camera Raw. All I've done is up the exposure from that and brought out all that detail. It's exactly the same image, nothing more than a change to exposure and a bit of change to contrast. You can see from that image that there is some vignetting. You'd have to tackle that in Adobe Camera Raw, but I tackle it with a plugin, which you'll see in the next image. So that's flattened it on the left-hand side with the plugin. And then I use a second plugin, which enhances the faint detail. And you can see it's brought up a bit more of the detail. You can do this with curves in Photoshop, and particularly by working with layers. The plugin just does it for you much more quickly. Next. Making a levels and curves adjustment brings even more detail out. Switching across then to Topaz takes a bit of the noise away. It does tend to lighten the blacks a little bit. So finally, just need an ultimate levels adjustment, as in the next image, which is the final finished product. And if you were to compare that with the original one coming out of Deep Sky Stacker or a single shot, there is a radical difference. This one, as you can see from the data, is taken on a 250mm lens at f5.6. It is cropped post-capture. 8 minutes total exposure made up of 5 seconds individual exposures, 96 of them stacked in Deep Sky Stacker at ISO 3200. But that's what you can achieve. Next. So now for astronomical targets, what you can point your camera at. So have a look at some photos and talk about how to do them. Yep. The easiest one is the moon, and we're coming up to full moon. Unfortunately, it's like portraits. Where don't you want to put the flash if you're taking somebody's portrait? The answer is on the camera. You get much more modelling when the light comes from the side, or at 45 degrees, rather than the on-camera flash. The moon is no different. You can get the contrast between the dark areas and the light areas, but you don't see very much contrast in terms of side lighting, lighting mountains and craters. So, not what you might think. The full moon is not necessarily the best time to photograph the moon, but it's quite easy to do. You see, this is a 1/200th of a second at ISO 100. I think Emilio's taken even better pictures than I have of the moon. Next. It's much better if you photograph the moon at a partial phase. because then you've got side lighting from the sun and it picks out those mountains and craters. So, and each night, as the moon gets steadily larger or steadily smaller, you get different craters lit. So you can have a whole set of different images. Next. I mentioned lunar eclipses. This is a partial lunar eclipse. A good time to photograph the moon, but we have to wait till next May to do that. But you can see, even when it's eclipsed, it is still lit. And that is because some sunlight goes through the Earth's atmosphere and gets bent onto the moon. And it glows deep orange red. Exposure time has to be substantially more than it does to capture the bright part of the moon, which here is burnt out. So here, it's ISO 500 and it's 1.3 seconds. So that's significantly longer exposure than capturing the sunlit part of the moon. Next. This is the only planet picture that's in here. And this is the planet Saturn just after it has passed out from behind the moon. The only time really it's worth using the planets in a photograph, I would think, is when it's close to another object such as the moon, and they make a nice pairing in the sky. Next. The sun is very difficult to photograph from a safety perspective. But I mentioned if you've got a hazy morning sunrise, as this one from Mahaka Playa, you can capture it. And if you're lucky, you might see a sunspot. That sunspot is there and represents a cooler region on the sun. Next. This one was taken through the fog as it rose. This actually was taken off from above Mahaka. Again, and on another day, and again, you can actually capture the sunspot. But I would strongly recommend you don't look directly through the camera, use your live view. Next. I was lucky with this. This was taken a couple of months ago when we had a partial eclipse, and it was completely cloudy. But the cloud broke just enough and cleanly enough to allow me a sharp image of the eclipsed sun. Again, I did this with live view, and I actually like the cloud. It gives an extra dimension to the image. Next. This is a foretaste of what you hopefully will see in 2026 and 2027, a total solar eclipse. This dates back to 2006 in Turkey and was captured on film. This is the last moment as the sun is eclipsed. You can see the atmosphere of the sun, the corona. This is called the diamond ring, where you have one patch of brilliantly intense light. Next. And this was the 1999 eclipse, which should have been visible from Britain if it weren't cloudy. I thought Britain is guaranteed to be cloudy, so I went to Germany and photographed this from Germany. But you can see the prominences on the sun. And this is the sort of thing that you should be blessed with in 2026, 2027. Next. Meteors. Have a look on the internet when meteor showers occur. The brightest and probably the best is the Perseids around about August the 11th. But there are some very good ones coming up in November. It's a good time of year coming up now. Find out what the maximum date, the best dates are, and around those dates, a few nights either side, centered on that date, find where what is called the radiant. And the radiant is the part of the sky where they're coming from. Look up that constellation on your app to see where it is. Put your camera on a tripod. Determine the maximum exposure you can get comfortably. In this case, for me, it was 20 seconds on a 10mm lens. And just leave it taking exposures and wait for a meteor to cross the field of view. I've go for a high ISO, in this case 3200, because you want to capture that meteor as best as you can. If you can recognize the plough in this image, well done. The constellation of the plough is there. Next one. Comets. If we're lucky enough to have a bright comet in the coming years, great. If not, there are a few fainter ones. Keep Googling comets, seeing what's around on the sky. You don't need to do it every week. Every couple of months is probably enough. You'll find any advance notice of a brighter comet coming in. This one, I think this one's Comet Lovejoy. The green is from oxygen. I said each atom emits lights at specific colours. There's a lot of oxygen in the atmosphere of this comet, which is excited by radiation from the sun, and when it recombines, it emits specific wavelengths, and that happens to be green. Next. This is Comet Virtanen. Again, green. Many of the comets, the fainter comets in particular, come out green. Next. This is the big showing from 2 years ago and was in the title slide. This is Comet Neowise that we enjoyed 2 summers ago. This one is a stacked image for 30-second exposures. Unfortunately, I didn't have my Astro Drive by the time I did these pictures. It gave me the inspiration to spend the money and buy one. Next. This is another picture of Comet Neowise. This also includes what's called noctilucent clouds, and I'm afraid you won't see them from southern Spain. The furthest south they've been recorded is Madrid, so it's only for those in northern latitudes. But the noctilucent clouds is the smoke produced by lots of meteors in the highest levels of the Earth's atmosphere. And in midsummer, that smoke can be hit by sunlight. And they are iridescent blue clouds. Next. Probably the object that you might want to tackle first is the galactic center, because it's probably the easiest and most rewarding. This is a single exposure taken 10 seconds with my f1.4 lens. ISO 3200. So no stacking in that. That's a simple straight shot. The problem is that even at 24mm, it's so big it fills the frame. Next. This is taken on, this again is a 24mm shot, but the next bit of the galaxy along from the previous shot. and it's stacked with a total exposure of 2 minutes 20 seconds. And you can see it records far more stars than the previous image. Next. And this is my ultra high contrast filter that fits between the lens and the camera body. Here it's pointing away from the galactic centre to a less dense part of the Milky Way. This is a region through the constellation of Cygnus, which is high in the, or overhead in the summer and autumn sky. I'll just go back and talk about the previous one. One more thing. The Milky Way, the centre of the galaxy, that is currently just visible after sunset low down in the west. So if you're wanting to take the best galactic centre images, you've still got the chance to do it. But it's a good time of day in that as soon as it goes dark, or as soon as the sky gets properly dark after sunset, it's visible in the southwest. Next slide. Now this is a magnification of the previous image. The ultra high contrast filter traces out the hydrogen. All that red in there is glowing hydrogen gas. The nebula you see, the bright one at the top, is called the North American Nebula, and I think you can see why just by its shape. But of interest as well in this picture, down to the lower left, you will see a couple of small arcs, bluish arcs. That is the remnant of a supernova, a star that exploded 2,000 years ago. And you can still see the remains of the expanding shell of gas from that star. Next. Nebulae and galaxies are probably some of the most beautiful things that you can actually photograph, but they do require tracking and stacking. This one you've seen, this is in Orion, the big Orion Nebula, coming round very nicely for the winter. Next. This is work in progress for me. This is the Rosette Nebula, also coming round in the winter. I need to increase the exposure and use my filter on this one. This is one I did last winter. So work in progress on that. Still a bit too noisy, not got a good enough signal to noise ratio. Something for me to work on. Next. By the way, this one is the raw capture, the raw data. So if you're pointing your live view and trying to find the nebula that was in the previous one, this is something what you will see on your screen of live view. So this is where Norton Star Atlas comes in to tell you exactly where the nebula or galaxy is. So you can use that in conjunction with the brightest stars in your field of view to point your camera in the right place, because don't expect to see it just looking through the camera. Next. This is the Andromeda Galaxy, by far the best galaxy to photograph. And that is a city of 100,000 million individual stars like our own sun. It's hard to imagine just the scale of that thing. That is a single exposure tracked, 3.5 minutes on the tracking scope that I've got. Next. This is just a field of view of the Virgo cluster of galaxies. If you look at it closely, you will see a lot of individual galaxies. And the fact is that probably half the points of light in this image are galaxies, not stars. It shows you just how big and how full our universe is. Next. The other half of the imagery is using the night sky as a night landscape. And the following images try to shed some light on that. Probably the easiest is to use the moon. If you use the moon at moonrise, you can do it in a straight single image shot. You do not need multiple exposures, you don't need stacking or anything. You can simply point the camera and press the shutter, as this one of the ships anchored off Garucha. Next. This one, on the other hand, I took the photograph. This was after sunset. You've got some nice tones in the light on the snow. You get a sort of a magenta-y, purpley light as the Earth's shadow rises. But if I exposed correctly for the snow, the moon was burnt out. So I put the camera on the tripod, took this photograph, and then very quickly afterwards, I took a second shot at a lesser exposure, which was correct for the moon. And I put the two back together again in Photoshop to create the single final image. So if the moon is too bright, then you'll need separate exposures for the moon and for the landscape. Next. This again goes back to the sort of first image where I've not bothered with overexposure of the moon. This is at Vienna in Alicante province, photographing the castle and the sky, and you've got the planet Venus and the moon above that. Night photography, when you include the landscape, can often be better with a little bit of light still in the sky. It just adds a bit of colour, a bit of tonality. Next. An interesting one, and this is looking out over Al-Fai. This is something called Earthshine. The dark side of the unlit side of the moon is actually being lit by light reflected off the Earth. If you go out on a dark night with a full moon, you can actually see a bit of the surroundings around. And that's because of light reflected off the moon. This is exactly the reverse, where the light is reflected off the Earth onto the moon. It can make for an attractive picture, and you want to do this, but it's best visible around the time of a crescent moon, early in its phase or late in its phase. Next. This is about 4 o'clock in the morning at the last total eclipse, when me and Emilio were mad enough to go out and photograph it. This is the eclipse moon over Mahaka, and this is a straight single exposure. The moon has been dimmed sufficiently well by the Earth's shadow to allow the whole thing to be taken as a single shot. Yep. And here is the eclipse moon over Dickie Bird's house.
Hey, on the left. Yeah,
I didn't actually know it was your house until after I took that picture.
That's nice. It's a nice picture.
Next. Comic Neowise last 2 years ago gave a great opportunity for single image photography. A little bit of dodging, yes, to lighten the white monument. But there I've got it over the city lights looking towards Manchester from the hilltops. Next. And it's a case sometimes about thinking, how can you create something just a little bit different? So here I've got the same monument as in the last picture, but I met this fellow photographer who was just up there photographing the distant cityscape. He wasn't aware of the comet at first, pointed it out to him, so at least he repaid the favour and acted as a model to illuminate the monument with his head torch, standing perfectly still for a 4-second exposure.
Oh dear.
Next. This one, in terms of trying to capture the Milky Way in an image, it is quite challenging. This is a single image, suffers a little bit from the actual camera noise. It was a 20-second exposure. The foreground, this is on Mahaka Playa, is lit entirely by the street lights from Mahaka. So I required a bit of dodging and burning, particularly dodging to reduce the intensity of the foreground, because there was too much street illumination in this. Next. On this occasion, I did a slightly different trick. This is Criccieth Castle in Wales. I was there again this last week, and I can't do the same photograph now, not very easily, because they've changed the lighting on the castle. But even back then, I was finding the light pollution from the street lights and from the castle was too much to make a nice shot of the Milky Way. So I took this photograph. I then went down onto the beach to the left of the castle in this image, and I took the photograph of the Milky Way away from that bit of light pollution. And when I got home, put the two back together again to make the single image. With something like this, it's quite easy to combine the two because you make a rough selection of the horizon. You then, if you've got the sky black enough, you can then use a blend mode of lighten in Photoshop to put the stars in. If on the other hand, you've got a heavily polluted light sky, you have to make a much more accurate selection. Next. Taking the night image a stage further, rather than allowing you just to capture what is already lit, you can go out with your own torch and light it yourself. You want a decent torch, quite bright, and some of the modern LED torches are pretty powerful now. And this is up near the tower, the old Arab Tower, between Maecenas, or beyond Maecenas from Mahaka. So it's a single image where the foreground is lit by a torch. And one thing I've learned, this was probably my first image that I did this on, you get a lot better image if you have the torch off to one side. So this suffers like the portrait with the on-camera flash or the full moon. There isn't as much texture and detail and relief in the image as you can create if you light with a 45-degree angle as opposed to almost on-camera torch. Next. This is another image taken similarly from the same location. All of these images, I've got my data at the bottom, so if you actually want to go back and check any of the data, do have a quick look at the data on the recording. Next. A much better way of doing light painting is this is one that I've got to thank Dave Beatson for pointing me in the right direction. Is to take multiple images. Take an exposure of the night sky, and then take other individual exposures, quite likely at a different ISO, of the foreground, lighting different elements of the foreground from different physical positions. So you move your torch, move yourself to light different bits, and then stack them all in Photoshop, change the blend mode to lighten, and then out pops your image. You may need to change and erase or mask certain bits. You may need to lighten or darken certain bits, but it's a much more powerful way of doing light painting. Next. And this is one that I did when I went up to see Dave at his location, a picture of a hail cannon. And you can see you can get quite artistic in the lighting by having light inside the building as well as outside of the building and lighting different elements of it. As far as the night sky is concerned, this is just general night sky. There is no Milky Way and no center of the galaxy in the backdrop. Next. This is how to stack the images. This is a selection of the layers. You end up with an awful lot of layers. You have at the bottom the background. And for me, I actually got 2 layers of background. But above that, you have your individual layers where you have photographed different elements of the foreground. As we work up, I've got the chimney, I've got grass bank, I've got tower, I've got another bit of the tower, tower left, tower right. For each of those layers, other than the background, if you set the blend mode to lighten, and you will have to apply a mask, as I have done, to mask out the sky, you then can paint in each individual bit of that image in a controlled manner. You paint on the mask in black paint or white paint to reveal or hide what's in the actual image. So by using a low opacity on the brush and painting in black, you can reduce something that might otherwise be too bright. Next. This, I think, is my favorite image resulting from that. It's made up of 15 different exposure layers, each one then blended by lighten mode to create this final image, which is a disused mine in the Peak District with Comet Neowise shining through a gap in the clouds. So I basically left the camera set to something like 15 seconds exposure. I set the drive to continuous, and then I went for a walk and just walked around it, lighting different bits. Certain exposures weren't usable, or certain exposures involved me walking from the left-hand side to the right-hand side. But in the end, there were 15 frames that were usable and important elements of this image, lighting the grass and lighting the buildings. Okay, I think that's the last one.
Yes.
Thank you.
Thank you very much.
Thank you very much, Trevor. That was very detailed and
Detailed.
Very good, Trevor.
yeah.
Yes.
Thanks, Emilio, for flying the system for me.
Don't worry, no problem. Happy to do it.
Yeah. No, that was good. That was very good. And I do have a recording of it. So, and it probably does need to be seen again. Yeah.
Yeah.
Mhm.
If you're going to take it up, yes, I think so. This is why I decided to use PowerPoint, because there is an awful lot of information. It's not, you don't want to be making notes.
Mhm.
Yeah.
Great.
Very good. Well, listen, if you could share the screen with me, I will just show you what the solar telescope output is. It'll only take a minute. well, you can share the screen yourself.
Oh, right, okay. Right, there we go. Have you got that?
Yep.
Yeah.
Yep.
That's through the solar telescope, where you can see the prominences off the edge of the sun, and you can see light areas and dark areas, sunspots and hotter areas. You can also start to see a little bit of the granular structure within the sun itself.
Mhm. There you go.
Fantastic. Thank
Good.
you.
Mhm. Yeah.
Yeah, very complex,
Yeah.
but very interesting. Yeah.
Mhm. That's very helpful.
Yeah.
David knows how to do the stacking with lighting the foregrounds also with the night skies. Mhm.
It's actually quite easy.
Mhm.
There's a guy,
There are some tutorials on the internet, aren't there?
I was just about to say that
YouTube.
Richard Tati is an expert. He's one of the leading people in night photography, landscape night photography. Richard Tati with 2 T's. He is worth a look.
Mhm.
Strongly recommend watching one of those YouTube videos.
Yeah.
It
Okay.
sounds complicated, but it isn't.
Now, there's a couple, he goes right through the whole thing, from taking the images right through Photoshop to the final image, and it's, when you actually see him doing it on screen, it's quite easy.
Yeah. You will also find there are tutorials on things like using Sequator on YouTube as well.
Very good, Trevor. Thank you very much. That was fantastic.
Yeah. Yeah.
Yep. Thank you.
Yes. Thank you.
You're welcome.
Trevor, you need to remind me. You remind me the dates of the Macenas season by the night. You remember the sky
The-
night and the eclipse, moon eclipse in Mojaca, because I can't find them.
Yeah,
Can't
okay.
find them. All right. I will have a look at those.
Yeah, thank you. Just,
It's a good,
I'll
there's
let
a
you-
good program I have on my PC, Stellarium. You use